right, I guess we'll get started. We have a good number of people and more people will filter in, but we can get started today. So thank you everyone for joining us for our Lunch and Learn on Machine Learning, and thanks for submitting your questions in advance. We received a lot of great questions and we'll try to get to as many of them as possible, so stick around for a Q&A at the end of our presentation. And our topic today is why your business should or maybe should not invest in machine learning. And we're excited to talk to you about that and give you some tips on how to approach machine learning for your business, and whether you're in the early stages, have already started considering it, or are just here to learn more. Hopefully we have some good information for you all today. So here's a quick overview of what we'll be discussing today. Just to go through this briefly, I'll welcome our speakers. We'll go over on a high level what is machine learning, the machine learning landscape, getting started with machine learning, how to know if it is right for you and your business, and then the Q&A portion, which we'll try to leave a lot of time for since everyone submitted some really great questions. And during our webinar, please feel free to use the chat function of Zoom to ask any questions you have, any questions that pop up, and we'll try our best to get them answered throughout. And we know we have a few different audiences here, so we'll try to save everyone from the super technical side of machine learning and the more industry specific questions, and let this be more of a conversation. And for our technical people out there, if you have more specific questions you'd like answered, we can follow up with you separately to talk about those. So before we get started, I just want to take a moment to introduce to you our speakers. We have Greg Sterndale, our CEO and co-founder. Mike Nicolaitis, we have is our CTO and co-founder as well, and Rob Hassler is our business development manager. So to kick us off, I want to ask each of our speakers to tell us a little bit about how machine learning impacts their role at Promptworks. So Greg, I'll let you start.
Sure, thanks, Sarah. Hi, everyone. I'm Greg, the CEO and one of the founders at Promptworks. And I work with our clients to figure out strategically if machine learning is going to be a fit for them, and it's whether it's something that they're going to be able to do or not as they're developing their products.
Hi, I'm Mike Nicolaitis. I am CTO and co-founder here at Promptworks, along with Greg. And yeah, I work with our clients and with teams to figure out how to implement their machine learning tech and develop their machine learning tech and integrate into their products or their systems or their processes that use that tech.
Hi, everyone. My name's Rob Hassler. I'm the business development manager here at Promptworks. It's great to see some familiar faces and some new faces as well. My role is I'm largely responsible for being the first touch point in helping our clients take their ideas for products and implementing things like machine learning from concept to execution, working alongside team members like Mike and the rest of our delivery team.
Great. Thank you, everybody. So we'll get started. We'll start a conversation by talking a little bit more about what machine learning is and is not. So we have this quote from our CEO, Greg, and he can talk about this in more detail, but he did recently write an article for our blog about the benefits of a machine learning strategy. So I'll encourage everyone to read that if you haven't already, but I'll let Greg take it away.
Sure. And some of you will be happy to know, I think this is probably the most technical slide that we have here today. But to give a definition, I'll read this. Machine learning, and specifically what I'm talking about here is supervised learning, is the process of building a model. You could also call that an inferred function that maps some kind of input to an output value. And it does so based on a bunch of examples, what you could call training data. And we're going to share some more examples of what this is here.
So we know that everyone's probably heard a lot of different things about machine learning at this point, and it can be hard to differentiate between what it is and what it actually isn't. So Greg will kind of walk us through the difference in these 2 points here.
Yeah, so these are some of the common things that you might use models generated from machine learning to do. So you might use these models to make predictions about trends, could be finances, could be something else. about the state of something. You could use it to make recommendations, for example, recommendations for products or services, content that you're consuming, recommended actions to take, or you might use these models to classify the state of something or behavior of users, for example. And I can continue this here. So there's a few things about machine learning that we should say that it's not. It's not magic. Some really ingenious products that use it make it seem like magic, but it's really more like statistics that's wrapped up in great technology and excellent user experience design. And it's certainly not foolproof. Even when you identify a great problem that you think could be solved with machine learning, it doesn't always work out. And it takes a fair amount of effort and knowledge to get that done. And it's not for everybody. We've seen a lot of great examples over the years, and we've also seen some big failures. Some of you might be familiar with something that Netflix did. They had a contest and awarded $1 million to a team of people for using machine learning to build an algorithm that would improve their recommendations by a certain percent. And they paid out $1 million for the winners of that, but they never actually were able to implement the algorithm on their service due to engineering costs and some other vague things that they never really talked about. But it didn't work out for them and was a costly mistake.
All right, so we want to walk everyone now through some real life examples to illustrate the point that even though machine learning might feel hard to quantify sometimes, it's really in many facets of our life, and some of which are very obvious to a lot of us and some which may not be.
Yeah, so the first example, and a lot of times for non-technical folks who have heard the terminology of machine learning, but might not necessarily know that they're running into it on a daily basis in their personal lives, is Amazon making recommendations. So in this case, Amazon devised an algorithm that began looking at items themselves. And what it does is it will scope recommendations through the user's purchased items that they've rated or talked about, and it will pair them to other similar items using metrics and composing a list of said recommendations. So an easy example is if you are interested in presidential history or biographies and you look for a book on George Washington, you might notice that alongside that, you're also getting recommended or pushed towards you other presidential biographies as well.
This is another example also related to Amazon, but some of you may be familiar with some of the home assistant devices, including Alexa, and those Alexa devices use machine learning models in at least a couple of different ways. One is to power the wake word engine that's running on the firmware of the device itself. That's the software that's always listening and processing audio clips, listening for someone to say the magic word that will cause the device to start paying attention. In most cases, for the Amazon devices, it's Alexa. And once the device gets woken up, it'll send the audio clip, the bigger audio clip, to the cloud, where Amazon will use natural language processing, which is powered by machine learning, to determine the intent of the speaker. And in this example, the intent was get a weather forecast, but it might be turn off the kitchen lights.
Another example I want to pull from one of our clients, and you may have used a product like this. So they have an app that recommends health insurance plans to consumers, to regular people, right? So they use machine learning to predict what your healthcare spending costs are going to be based on your demographics. So like they take your age, sex, location, smoking, stuff like that, and from that they can predict the cost of doctor's visits and drugs at the pharmacy and emergency room visits. And then once they have a prediction, they kind of just wrap that up and they go through every health plan that you have available and say, okay, with this health plan, if we factor in co-pays and premiums and tax benefits and stuff like that, like what's the real cost? Like what's the real bottom line going to be for the person? They go through, just all the health plans that you have. So it's a pretty like clever use of machine learning to fill a somewhat niche, but also like it's kind of niche, but not niche at all. Like everyone has to deal with that kind of problem. And they're kind of in contrast to the Amazon examples before, they're a small startup and they've done well. And it's kind of an example that machine learning is not just for the big corporations anymore. Like it's becoming more democratized and things, smaller companies can start using it.
Great. So thank you. We've gone through some of what goes into machine learning, how to utilize it, and now we'll move on to how to know if machine learning is the right solution for your company. We have a quote from Rob here, who as our business development manager, like he said, has a lot of experience walking our clients through this process, assessing their needs and expectations when it comes to machine learning. So Rob can talk more about this.
Thanks, Sarah. Yeah, I think for starters, a company really needs to assess where and when machine learning might make sense. And one of the biggest factors is that it will require a significant potential investment, and there's also some risk involved. So the question you want to ask yourself is, will that return be worth the investment? One fairly straightforward example that I like is the example of a company whose product saves their customers money by identifying employee spending that's not compliant. So originally, this company started by hiring a lot of people to sift through employee spending data in order to find suspicious expenses. And those people were expensive, and the solution wasn't able to scale very well. So in turn, someone at the company suspected that they could use ML to create a model, and that model would flag suspicious expenses faster, more accurately, and at a much lower cost. So what I like about this example is it doesn't change the nature of their business model or offering for their customers, but because they recognized that they were trying to solve a problem where they needed to, they were able to make something more accurate, do something faster, and recognize patterns. In the case of this example, it was able to be successful because they had a lot of data that they could train said model with.
I'll let you continue on this slide, Rob.
Sure. So oftentimes people reach out to our team here at Promptworks for different reasons related to wanting to utilize machine learning or NLP. And there are a few specific problems that companies tend to come to us with. Some of those are listed here. So as you're taking a look at this list, think about which of these items you've either tried to implement at your company or your business, or some of those things that might ring a bell and you're trying to implement them in the future. So the astute reader will recognize some of these as things that are really different examples of the same concept. So in reality, it doesn't really matter if you're dealing with things like tweets, retirement accounts, expense reports, resumes and candidate pools, heart rate sensors, or even video clips. If you're tasked with solving problems that sound somewhat like this, it might be time to start asking around internally if machine learning is right for you.
Right. So now we'll move on to talking about how does one get started with machine learning in your own company or business. We have another quote from Rob here who can tell us more about this.
Sure. So the idea here is that models aren't magic, as Greg mentioned, but the approach also is not magic. It's essentially taking cues from things like scientific method, being pragmatic and iterative. So great businesses and products often start with the people within the organization who have a clear understanding of the problem that they're trying to solve, maybe a few ideas about how to do so in a novel way. And then they also have some kind of unfair advantage in their given industry or market. So in this case, we're talking about using ML to create a novel solution using data as that unfair advantage.
And now from a more technical perspective, Mike, can you tell us more about what companies need in order to start pursuing machine learning?
Absolutely. So I break it down into these three categories here, and I'll talk through them a little bit. So the first thing you need is data, right? So one of the common questions and concerns is like, how much data do we need? And it really, I mean, I'm trying not to say it depends to like all those sorts of questions, but like it depends on the complexity of the problem, how determinative your input is. You know, generally, if you're doing, like, if you're trying to make predictions or make classifications of things, you're gonna, you probably need thousands, maybe millions of data points if you want to do a really good job. Often for smaller projects, like having enough data is really a significant like limiting factor for them. So that's something to keep in mind. To go into that a little bit more, you know, data means different things in different contexts, right? So like if you are predicting events like outcomes, if you're predicting when hardware is going to fail or predicting trends, that sort of thing, you're going to need a lot of data. If you want to do something like recommending videos or articles based on, you know, what other users who watched this video, you know, they also watch these videos, like that sort of thing. It's called collaborative filtering. Your data there is the is like the user history, like the who has watched what video and when. And so like you have to find ways to get that data. But if you're doing something like natural language processing, somebody has already kind of done the data work for you, right? So natural language processing, researchers have like gathered thousands of books and millions of tweets and emails and stuff like that and kind of crunched all that. And so you can kind of, there's off-the-shelf packages where they've kind of already incorporated the data, and you can use that to you know, make smarter decisions about text that you have, whether it's like a chat bot or responding to like reviewing resumes, that sort of thing. And then, yeah, same goes with like facial recognition. Like that's a researchers have put in a lot of work and kind of already incorporated the data. So if you're trying to do something like that, you're lucky in that you know, you don't have to source all that data yourself. But that's like the first starting point. There is like, you got to figure out what data you have and what data you're going to need. The next part in the middle here is tools that are going to crunch that data. So you have to take that data and you have to turn that into models. Like you turn that into something that can actually, you know, make a prediction for you in most cases. And so if you have a lot of data, or the process for building these models needs to be continuous, like you have to have somewhere that happens, right? So like if you have a platform already that your software is running on or running as part of, you might have some mechanisms already built into that platform that you can kind of hook into, and maybe even have some machine learning packages built in. But if not, the good news is that there are like a bunch of tools and platforms and open source free tools that you can use to do the processing of the data and building the models. And like all the cloud providers, AWS, Azure, they provide a lot of packages and support out of the box to make it, you know, easy now. So it's real, like, and for the most part, these tools, they're going to live in the cloud because that's kind of the world that we're in right now. And they've made it easy enough for us to do that. And then the final thing that you're going to kind of need to get started is a team. So one of the interesting things about machine learning projects is that they have a tendency to cut across disciplines. So, you know, there's the data science, right? The statistics and dealing with the data, but then there's the engineering of the data and engineering of the software and the infrastructure. But then on the less technical side, like at the end of the day, as was mentioned before, it's, you know, it's people who are the recipients of the machine learning, whether recommendations or predictions, or like there's people on the other end of it. So you need design, you need designers to think hard about how you're going to incorporate the machine learning into the workflows that you currently have in a way that's not going to be disruptive, in a way that's going to have, that people are really going to understand and take advantage of. Yeah, so if you're in an organization where you can assemble a team like that, that's great. That's relatively rare, but that's a great place to start. Otherwise, there are firms that you can hire. Like sometimes they do webinars Thursday at noon, and they can help you with these things too.
Cool. And Mike, can you talk more about the process now? Yeah.
So, let's say you've got a sense of what your data is. You might not know your tools, but you have people who can work with the tools, and you have a team. Like I wanted to talk about kind of what the process is from going from you have an idea to you have machine learning running in production in your system and as part of your process. So like this slide here, you see this loop, this circle here. If you're familiar with the scientific method, like there's a lot of overlap here. And one of the things that you'll notice right away that it's an iterative process, and I'll talk a little bit about that. So let's like use a more concrete example to kind of help. I want to talk through kind of these different phases here. So like let's say that you have an online video platform, like maybe like a Netflix kind of thing, but you host a lot of like educational video content, right? So starting from the hypothesis, you might have an idea. So like, I think we could provide better recommendations for what videos for people to watch next. Like, and you have a better sense than just that. Like if you're looking at a video, we can say people who watch this video tend to watch these videos, so let's recommend these videos. All right, so in the hypothesis phase, like what you're trying to do is clearly define the problem that you want to solve and the improvement that you want to achieve. And this is, from the data science side of things. Your data scientists are looking at like, well, what techniques can we use, and which ones have been known to work in the past, and what are their limitations, like that sort of thing. And your product person, it's a product manager, just somebody in a product role, you want them to be thinking like, what's the value to the users, to the business? Like, what's the value that we're trying to get out of here? And then everyone who's involved at this point needs to be thinking about like, how do we know if we have succeeded at this? So at this stage, you're trying to get to that as kind of like your output here. Once you have that, moving on to the research and discovery, this is like 2 o'clock, the kind of light blue arrow. This is kind of where things really get started. So like looking ahead, ultimately, like what we're trying to do is we're trying to take machine learning or some solution, machine learning or otherwise, and put it into our product or into our process. But we have a few of these phases beforehand, and the point of these phases is we're trying to help ourselves find a way through the maze of different options and possibilities and pitfalls, because machine learning is that type of thing. Data is kind of finicky, and if you don't take these, if you don't do this earlier work, you're liable to spend a lot of time building out a solution, and then you went the wrong direction because you didn't, and you kind of have to scrap a lot of what you did and kind of start over. So that's a little bit of context for these phases. So the research and discovery phase, we're trying to answer, can we accomplish this? Like, can we really do this? How? And then also, like, is this worth doing? How will we know if it's worth doing? How do we know if we've, how do we know what how do we know what our ROI is? And this is really a cross-functional, cross-discipline effort here, right? So the data scientists are diving into the data. How is it? What's the quality? Is it good enough? Is there enough of it? Engineers are looking at like, what tools do we have available? How do we integrate them into our platform? The product people are talking about like, what metrics are we going to use? How do we calculate ROI? What ROI would be too low? And here's like, I'm getting a little bit into the weeds, but I wanted to kind of call this out, is that crucially, user experience is like a really important part of this phase. And your UX people should be asking, like, will this help our users? Are they going to take advantage of this? Can we provide these machine learning insights or whatever it is, predictions, recommendations? Can we provide this in a way that our users are going to understand and like actually take advantage of? So not to get into a story, but we've seen firsthand how companies can invest a lot of money into their machine learning tech, and like the machine learning works, right? So it consistently makes better decisions than the trained staff does. They can prove empirically that they've made better decisions. Like if you did what the machine learning models said to do, we would have been better off. But the trained staff don't take the advice. They don't take advantage of it. And for whatever reason, like they don't trust it. They have other motivations. It's corporate politics. So like the project succeeds on a technical level, but like as a business initiative, like it's a failure. So that's why like user experience is kind of crucial here. You need to know, you want to have confidence that your users are going to take advantage of the benefits of the machine learning. And often if you're in the role of like an innovator, right, your job is to shake things up, right? And so people don't always like when things are shaken up. So like this is why you really need to kind of get to the bottom of this before you invest a whole lot of money and time. Okay, so that's my spiel about the UX side of the research and discovery. So once we do that, we're moving on to building a prototype. That's the orange arrow on the, like, what's that, 5 o'clock, 4 and 5 o'clock. In a prototype, you've probably seen examples in other industries. Like if you've watched like car makers, that they'll make these clay models of cars and they'll put them in the wind tunnel to see if the aerodynamics are working the way they expect. And they do that because it's cheaper to build another clay model if you have to redesign the car than it is to build another car, or God forbid, another assembly line, when you find out that it doesn't quite work the way you want. So we're doing the same thing with software. So the data scientists, the data engineers, the software engineers are quick and dirty tools that we can use to prove that machine learning works, without having to build it and integrate it into our app. So whatever we can kind of jerry-rig and kind of, we need that proof before we kind of do that, before we make that big investment. And on the UX side, the user experience side, these prototypes are like clickable mockups, right? Like screens that they put in front of real people to watch them. In our example of like video recommendations, if you put the screen in front of people, will they actually click on these recommendations, right? And then finally, once we do all that, and we're satisfied that we can actually do this, we move into the implementation phase. And that's where we build it out and we put it into our software, into our workflow, into the process. So it's adding the screens, building out the data pipeline so that the models are kind of consistently trained as time goes on, that sort of thing, and deploying it all to the cloud. So after the implementation, like, okay, so finally we're done. We've deployed it. It's running in production. Our users are getting to interact with it. So this is now where our product people are now watching the metrics, right? Like how, we decided much earlier, like what those metrics are going to be that we're going to look at. We can start looking at them now. Are we getting the ROI that we're looking for? Is this, effective the way that we wanted it to be? And the UX people, user experience people, are doing, gathering, talking to users, gathering feedback, and doing some research to make sure that users are kind of, happy and or like getting the behavior that we want from users. So what happens now? Well, inevitably you have another hypothesis, right? So maybe it's a way to improve on the first version. Like if it went well, maybe it's improvements. Maybe it's like, okay, it didn't go well, let's try to fix it. Or maybe it's like applying the same techniques to other parts of the app. But you start over. You have a hypothesis and kind of go around the loop again. And you want to do this iterative phase. I don't think I need to preach about iterative development to this crowd, probably. You're not going to get it right the first time, inevitably. So give yourself a few tries. This is the model that we think is kind of most appropriate for developing machine learning technology for your product.
Thanks, Mike. You want to talk more about data here?
Yeah, okay. So you have like, I kind of want to talk about like, so now you have a kind of a high level sense of the process. I want to talk about like, well, how do you like get started into that, right? So like you'll have a hypothesis, or so I should say maybe you have a hypothesis. And that's where you can, start to formulate that, turn that into like, how do we know if this thing worked, right? Turn it into like something solid that you can actually iterate on. And then you move into the research and discovery phase, dive into your data, see what you have your UX people get started immediately, have your designers get started immediately, because you want them to be, that's going to be guiding kind of your implementation of your other team members. So maybe you don't have a hypothesis, right? Maybe it's like, could we use machine learning to improve engagement, to predict demand, predict failures? Well, the place to start there is kind of the same thing, right? You start narrowing in on what metrics and success measures you have, like, and how you know that you like start narrowing in on that. What moves the needle for your organization, and simultaneously like exploring what sort of data you have. Have somebody that can get up to speed on like what data you have and what it means, and kind of diving in to kind of you start a conversation that way about what could we do to improve things if we think that we might be able to use machine learning. So from there, maybe it's bringing in a partner, maybe that's you having somebody in your organization with some affinity, kind of getting started on that sort of stuff. Yeah, and so from those places, those are good places to start. And the loop in the previous slide, that process, like it's not a paint by numbers approach, but it's a general map that how to approach projects like these. And so I think that's a good kind of starting point.
Great. Thank you so much for all of that, Mike. A lot of good information. And after all of that, I feel like it could be a little overwhelming to implement all of this internally, like Mike talked about. So Greg can talk about a little bit more about what a role a partner can play in your machine learning process, whether it is a development shop or external machine learning experts.
Sure. Yeah, I can talk about that. Mike's already talked quite a bit about some of the different concerns that are involved in building out a product that uses machine learning. You're going to want a team that's going to be able to help you to define very specifically what problem it is that you're trying to solve. They should also help you come up with that hypothesis and the success criteria for whatever it is that you're going to be able to solving. And you're going to need a team to help do the data science, to design and build this model with machine learning, and also to help you with that strategy, the design of the user experience, and the engineering to implement that product or tool that will make the prediction, classification, recommend videos, whatever it is for your users. And some of the titles that might be involved in a team like that, it's going to be someone like a business strategist or product manager, data scientists, UX designers, and software engineers, to say the least. I expect there to be project managers as well. So if you have that team, or you think you can build one quickly, then you probably don't need a partner. But if that's not the case, then you should probably look for a partner, and one that has some real experience and expertise with machine learning.
Yeah. Awesome. So that is all that we have for today. Thank you, Greg, Mike, and Rob, for all of your insight And thank you everyone for attending. So I'm going to jump into the Q&A portion of our talk because we did get so many great questions. But again, if you have any pressing questions, feel free to type them into the chat even now. And if we don't get to your question, like I said earlier, do not worry because we will follow up with you to see if we can answer your questions one-on-one after this chat. So otherwise, I will get started with some of the questions that we have already. So let me start with, we have a question here. How will machine learning affect the labor market? And will machine learning replace some jobs? If so, which ones?
I can attempt to answer that one, but really I think it's a question probably for an economist. I guess I can say with confidence that machine learning and more broadly artificial intelligence can and has already replaced jobs. And I think you asked which ones. I guess I would refer to what we had talked about earlier about the types of problems that you can solve with machine learning. If a job is primarily solving those problems, and there's a chance that it could be replaced, maybe in part or in its entirety with machine learning. And I guess maybe anecdotally, I could say that it's not just folks that are paid a minimum wage to sift through some kind of expense report that might be at risk, or part of their job might be at risk. I can say that there are parts of my own brother-in-law's job, who's a big-time Wall Street trader, and then parts of another friend's job, who's a financial advisor for high net worth folks. And parts of their job are being replaced with models that are created with machine learning. So there's that. And then I guess kind of on the other hand, there are opportunities abound for folks in the data science and engineering field. And in fact, if anybody knows folks who are looking for a job, please let me know because I'd like to talk to them.
Great. Thanks, Greg. This might be another question for you, or anyone else can jump in. How do you assess organizational readiness for machine learning, particularly decision makers? Or how can I sell ML in my organization?
Maybe I could take a pass at this one. So oftentimes we've had people on both ends of the spectrum, so to speak, reach out to us about wanting to implement machine learning. On one end, you have someone internally who is seeing ways in which business processes might be able to be automated, and they're wondering, they're the people with the hypothesis, and they're reaching out to us to see whether or not it makes sense and we could potentially help them with it. The other end of the spectrum is perhaps decision makers who are less technical, but they've heard about machine learning. They know loosely it can help their business, and they've given it the task to someone to say, hey, can you talk to someone who might be able to help us utilize this? So I think the Phillies are playing as we speak. I'll use a baseball analogy. Don't try and hit a home run on your first at bat. Maybe try and get a few singles first. And the concept there is a lot of companies have low-hanging fruit. And the low-hanging fruit might be they have data cleaning that they can do or improvements to their data pipeline. And those things don't need complex machine learning to be solved. So in theory, by doing something that might be low-hanging fruit, you'll be able to have tangible results and actionable insights that are obtained from some of those things. And it will help increase your momentum with bringing those ideas to decision makers, and also perhaps instilling confidence in them by showing them some low-hanging fruit results.
Great. Thanks, Rob. We have a question from the chat here. Is it time or budget intensive to get started with machine learning?
Take a stab at that. I'd say it doesn't have to be, but it can be. I think that much like any other kind of product development, it's going to be time consuming and risky. Often that time is what's expensive, but If you've already got a big data set that you could work with, for example, and maybe you have some time of your own to invest in learning, you may be able to do some of this, on your own at a lower cost, depending on how you value your own time. But in general, I'd say it's on par with any other kind of product development.
I jump in and want to say that so that's kind of the reason that that loop that I talked about is structured that way. Like why you do the research, or you start with a hypothesis, then do a lot of research and discovery, is to keep it from kind of ballooning up into something huge, especially if it's not necessarily going to work the first time, right? So those early stages, if you kind of take that approach, you can find out. It's hard to answer right off the bat. Is it time intensive? But if you have a sense of the problem and start diving in, you can kind of build that picture without spending a ton of time and money. But the farther you're around you get, the more you'll know, and you want to kind of figure out when to make that go no go decision as early as possible, and you can use that process to do that.
I feel like that addresses a question we just got. How much time is typically spent on each process loop? Do you want to add anything else to that, Mike?
Yeah, I mean, it's very dependent on what the project is. You want to make those loops as small as possible. So like that takes some ingenuity to try to figure out how to make this small. If you're just, if you're just starting out, you have nothing to build off of. It's probably the research is probably going to be a lot higher, a lot more of that time spent there. And probably all of it really, because you're not like modifying an existing system once you get to the implementation phase. So if you're building a new system, like that piece can be larger too. But again, like in that research and discovery phase, in that phase, that's where you're trying to figure out like, well, maybe there's a way we can do this cheaper or without machine learning, like just something simpler, something that's not gonna, maybe there's another, and sometimes it's like, maybe there's a way to do this project that's not even technical. Like, what if we just change the copy on the website? Yeah. Sometimes that is like those kinds of things. Non-technical solutions are the right way too. So that's kind of a long non-answer, but I hope those kind of illuminate a little bit of the factors involved.
I can chime in with a couple of examples that might give you an idea about the time for each loop in that process. And they're the most extreme examples I can think of on either end. In one example, we did some work for a client where the entire loop took 2 months, I think, to go through, from hypothesis all the way to deploying working software. And then this other example, which was slower, this is a client that we're working with that has an academic institution that's developing the ML models. They have this kind of third-party relationship with them, and the R&D process for them, just the R&D, is now 2.5 months long. So the whole process goes a lot slower, and part of that might just be because it's academia, but it's a more challenging problem to solve, and therefore takes a bit more time to build. In their case, a very accurate model.
Yeah. I feel like that's a pretty good segue into the question about where do product builders go wrong when starting out with ML, or can you share a client experience where you had to redirect the project?
Sure. Yeah, I can do that. Is that one at me, Sarah?
You, anybody?
I'll take a pass. Where do product builders go wrong when starting out with machine learning? Sometimes we see folks with a solution in search of a problem. And I guess another way to say that may be that those product builders didn't have a really well-defined problem or hypothesis tied to like the business's bottom line. Also, a different scenario there where product builders might go wrong is we see them doing like a lot of pre-optimization. And this may be what Mike was hinting at a minute ago, where they're using machine learning to solve problems that they could have solved in another way, maybe less effectively, but that would require significantly less investment. And if they could prove out the concept, then someday they might come back and solve it more efficiently or effectively using machine learning. So we see that. And I think you had asked about redirecting a client. Yeah, okay. So I can think of an example where one of our clients came to us trying to predict the cost of kind of big construction projects. And they had a very elaborate rule-based way of calculating or predicting the costs. What's the size of the building? If it's greater than 10,000 square feet, then multiply by 1.2. And if it's greater than 20,000, multiply by 1.6. It was very, over time, very built out. They had built something out in Excel and then turned it into a software. And they were finding that the predictions were not particularly accurate enough, and came to us for help. And we asked if they had a big data set of past projects and what the actual costs were, and some attributes about them. And our hypothesis was that we could use machine learning to make these predictions instead of this kind of rule-based thing that they had created on their own over time. So we redirected them, I guess, to ML, and we're able to make more accurate predictions using that technique.
Great. I have a couple more technical questions that let me know if these we've kind of already answered. Are there general guidelines for what data structure and scale are best for machine learning to be reasonably effective? I feel like, Mike, you already talked a bit about that. Is there anything else we want to add?
Yeah, it sounds like a getting started, like how do we start off on the right foot kind of question. I would say that it's when you're getting started, especially in the early phases of the project, the research and development and discovery. The thing that you really want to optimize for is accessibility, right? Because you're kind of like you're doing, it's very exploratory, and so you're trying a lot of things and seeing what works, and you're going to try things like, well, what if we flip it around and invert it, and then can we get better results that way, like stuff like that. So what you want to do is optimize for accessibility. So if you are comfortable in Postgres or in SQL, use a SQL database, even if you're not going to use that when you get into production. If you have all your data in Hadoop, you like to do things that way, do that. Do what's most comfortable, because the goal is finding a solution, not you're not trying to hit a home run on the first at bat, right? You're not trying to build out a perfect system all at once. So I'd say I don't have anything more specific than that, but those are the kind of concerns that you're going to try to be optimizing for.
Okay. Another one maybe for you, Mike. How do you weigh the effort of training ML against Mechanical Turk?
I love this question. Yeah, so for folks who aren't familiar with Mechanical Turk, they've called it artificial intelligence. So what it is you have actual people making decisions. So maybe it's going through receipts and pulling the numbers out of receipts and putting it into some specific format for you. Just one random example, but the idea is you can put people behind these tasks instead of train a machine learning model to do it. So, and the reasons you would do that is, it's cheaper. It's cheaper to start and easier to start. And so there's a lot of good reasons to do that. And there's many more. I'm not going to get into them. But so when you're weighing the effort, should we train ML models or should we use Mechanical Turk? Again, I think these are the considerations that I would take. The one is well, how hard how hard is your problem for machine learning and how hard is it for a person, right? So if it's really easy for a person and hard for machine learning to train a machine learning model to do this task, then like that's something to consider, right? There's also like risk, right? So machine learning, look at your problem, and you might not be able to succeed with machine learning. Like if you know that a person can do this task, and you know you can succeed that way, you're going to weigh the risk of do we invest a lot to build a model, or do we just put people in front of it? Other considerations are like speed. So like machine learning can be a lot faster, and so does it really complicate things for your users if they don't get answers right away? If so, then maybe you do need to kind of go the machine learning route rather than wait for a person on the other end to kind of like categorize stuff or do whatever task they're doing. Yeah, and I think, yeah, and sometimes, so it costs also, like machine learning is usually more costly up front, less costly over time. Mechanical Turk would be like less costly up front, but like consistently costly over time. So you kind of have to like weigh those. That's hard to do. So yeah, so those considerations. And then I'd also throw in another thing here is that often you can kind of use both, right? You can use machine learning to augment what a person's going to do. So like if you're pulling numbers out of a receipt, you can use optical character recognition to like pull those numbers out. And so the person is not typing each one by hand, they're just kind of like correcting what the computer took a first pass at. And those are kind of my favorite, where you can actually kind of get the best of both worlds by combining them. But so I hope that's like a helpful set of considerations.
Great, thanks. We have 5 minutes left. I think I'm going to try to do our last 2 questions from the chat. So we'll do this one first, this really specific question. I'll try to read it out loud. It says, I run a factory and am interested in integrating ML functions to assess SKU flow through the shop floor from raw material to finished good. The purpose is to provide feedback to managers in real time about manufacturing flow. We also want to improve forecasting, material acquisition, and bottlenecks in our processes for 150 metal SKUs. Is this an area where ML could improve our capacity and reaction to order demand? Who would like to take that question?
I can take a stab at it. So sounds like a cool set of problems to have. I don't know that you would need machine learning to help solve all of those problems. It sounds more like you might want to do I think it's called a throughput analysis, if you haven't already. I think it's a common thing used in manufacturing. We've worked with one of our clients on doing a similar process in the past when trying to design software to help automate parts of it. And in some ways that ML might be a fit here, just after hearing these couple sentences. When you talk about forecasting, there's a possibility there. If you're forecasting, say, demand, if you have a data set that we could use or you could use to train a model, that's a possibility. And material acquisition, I think you said in there, if you're trying to inform decisions about when to buy materials based on trends in demand, maybe machine learning would be a fit there. So happy to talk more about it, maybe offline if you like.
Great. Yeah, we can follow up on that question, absolutely. And we have 3 minutes left. I'm going to do one more question from the chat. If I'm on the technical side, how can I explain machine learning to my non-technical colleagues?
Ooh, I guess I'll take a stab, and I'm very curious to hear if Rob or Mike have any tips or tricks. It really depends on who I'm trying to explain it to, and their background and context. Examples often help. We tried to do some of that earlier in the presentation, things that they might be familiar with, and explaining, here's how Amazon comes up with these product recommendations, uses a whole bunch of data or examples to learn from in order to make an informed guess at what somebody else might want. So that's one of my favorite ways of explaining things, is just using examples.
Yeah, I was going to add analogies for non-technical folks is often a great way to give them a sense of the technical version, and also just keeping things short, explaining certain things in a concise manner. I actually, in the software world, the building a car analogy is used often. And as Mike mentioned, even just the concept of research and discovery, going into the prototype and using, the clay car before building the actual car. I myself am a non-technical person. So analogies like that are very easy to picture and understand, and then segueing that into ways in which those processes can help with things that are supporting your business, and maybe it even relates to that individual's job, I think are things that are relevant as making it easier to explain.
I might add the, taking specific examples, or at least specific clusters of examples, it can be helpful, because machine learning is statistics and software engineering combined. It's kind of like, how do you explain statistics to somebody who doesn't know what statistics is? That's gonna be hard. But if you can take examples of the Netflix example, where people who looked at these videos also looked at these, that's a lot easier for someone to understand. And then you can kind of build on small examples like that. So just one thought.
Yeah. Does anyone have anyone else from the panel they want to add before we wrap up? It's, I think, exactly almost 1 o'clock. Good. All right. Well, thank you everyone for attending. We really appreciate it. Thank you to our 3 speakers today for giving their time and insight into machine learning. We will be sending follow-up emails to follow up with everyone individually if we did or did not get to your question, and we will link the recording of this webinar here. If you wanted to go back and listen to a part of it again, share it with anyone. For those non-technical folks, if you want to send it to them just to, answer your question. But otherwise, thank you so much, and everyone have a great rest of your day.
Thanks, Sarah.
Thank you, guys.
Yeah, thanks, Sarah. Thanks everyone for coming.
Thank you.